In the given problem, since M2 is not fixed to the surface, it will move due to the normal reaction from M1. So the situation will be something like this. Note that M1 is not moving along the incline of angle theta as seen from the reference frame of the ground, though it still slides on the surface of M2. This is because the surface of M2 is also accelerating towards right. So the acceleration of M1 with respect to ground will be something like this. But in the reference frame of the wedge, M1 is still sliding down its inclined plane. Since the situation is simpler in the reference frame of the wedge, let us solve the problem from the reference frame of the wedge. Let us say that M2 has acceleration a2 towards right with respect to ground, and M1 has acceleration a12 with respect to M2. Considering the free body diagram of M1 from the reference frame of M2, we have the pseudo force M1A2 towards left, M1G downwards, and normal reaction N from the surface. And acceleration a12 is along the incline of the plane, since from the reference frame of M2, a2 is equal to 0 and M1 just slides down the inclined plane. So writing equations along and perpendicular to the inclined plane, we have M1G sin theta plus M1A2 cos theta is equal to M1 into A12, and N is equal to M1G cos theta minus M1A2 sin theta. Now considering the free body diagram of M2 from its own frame of reference, we have A2 is equal to 0. But in this frame of reference, M2 has a pseudo force M2A2 towards left, normal reaction from M1, normal reaction from ground, and weight M2G. Writing equation along horizontal direction, we can say that N sin theta is equal to M2 into A2. Using these equations, we have M2A2 by sin theta is equal to M1G cos theta minus M1A2 sin theta. Solving for A2, we get A2 is equal to M1G cos theta divided by M2 divided by sin theta plus M1 sin theta, which is equal to M1G sin theta cos theta divided by M1 sin square theta plus M2. Substituting this value in this equation, we have N is equal to M1 M2G cos theta divided by M1 sin square theta plus M2. And from this equation, we get A12 is equal to M1 plus M2 into G sin theta divided by M1 sin square theta plus M2. And now for finding the acceleration of M1 with respect to ground, we can say that acceleration of 1 with respect to ground is equal to acceleration of 1 with respect to 2 plus the acceleration of 2 with respect to ground. That is, the acceleration of M1 with respect to ground can be found by the vector sum of the vectors A12 and A2. Resolving A12 into components, we have A1x is equal to A12 cos theta minus A2, and A1y is equal to A12 into sin theta. Therefore A1x is equal to M2G sin theta cos theta divided by M1 sin square theta plus M2, and A1y is equal to M1 plus M2 into G sin square theta divided by M1 sin square theta plus M2.